let's talk about adding and subtracting like radicals. And this is similar to what we did with like terms, in that when we add and subtract, we need to make sure that what we're adding is similar. And so specifically what we want to talk about in our like radicals is a like radical is any term where the index and radicand are the same. So, let's look at some. Square root of 5 and square root of 5 are like radicands because they're exactly the same. 3 square roots of 2 and 2 square roots of 2 are also like radicals because everything about the radical is exactly the same. So just like our like terms, when we have like radicals, we combine them. So suppose we have 5 square roots of 2x plus 9 square roots of 2x. Because the radicals are like, we simply take the operator and combine the numbers. 5 plus 9 is 14, and then we leave the root 2x the same. As another example, suppose we have 3 cube roots of 10 plus 7 cube roots of 10 minus 5 cube roots of 10. Since the radicals are all the same, this means our answer is going to have a cube root of 10. We take a 3, a plus 7, and a minus 5. 3 plus 7 is 10. 10 minus 5 is 5. So if our radicals are the same, then it's very easy and very straightforward to keep them together. Now, sometimes they don't start the same. Suppose we have 3 square roots of 12 plus 7 square roots of 3. And these are not like radicals yet. There is a possibility that they will be like radicals, but that depends on if they simplify. So before you talk about whether something is a like radical or not, make sure you simplify it first. So the square root of 12 becomes 4 and 3, and a 4 comes out, times as a 2, times to the 3 on the outside, so we end up with 6 square roots of 3 plus 7 square roots of 3. Now we have like radicals, a square root of 3 in common, and we add the 6 and the plus 7 to get 13 square roots of 3. So always, always, always simplify your radicals before you say whether they're like or not, before you add them together. Okay, the last example that I want to look at is a little bit tricky. So we're going to first assume all variables are positive. And so we're going to look at 3/4 root of m to the 4th n minus 5m 8th root of n squared. And at the moment these don't look like they're very simplified, or that they're like radicals at all, because it's a 4th root and an 8th root. Well, let's break this down. 4m's underneath the 4th root gives me an m on the outside, and it stays as the 4th root of n on the inside with a 3 in front. That's already there. The 3 just copies down. Now the 8th root of n squared is the same as n to the 2/8, which reduces to n to the 1/4. This then becomes minus 5m 4th root of n. And if you notice, we created a like radical when we simplified both of these unlike radicals. So then we just take our 3m minus 5m and get minus 5m 4th root of the square root of n.